the equilibrium point will be maintained irrespective of any initial condition, and for other type of system where the equilibrium point it may not be reached for all type of equilibrium point.
So basically the system itself needs to be characterized when we talk about.
Exactly, I am coming to that point. Yes.
I would like to add on what you said before. Let us assume we have two equilibrium points. If we are here, if my perturbation is small, then I'll come back to this equilibrium point. But if my perturbation is large, then I'll move away from this equilibrium point and go to this equilibrium point. So the idea in that definition, we have to add some perturbation limit up to which it will stay in that particular
Same
equilibrium.
I'm coming to that. Why that definition shouldn't be modified, but what you said that is also true, but how that comes into the point that I will now
I think so,
discuss.
sir, that equation x dot equal to 0, sir has not mentioned about one single equilibrium point. It can be any equilibrium
Exactly.
point.
This is a good point. Perhaps what he said, that is when we find the equilibrium point by solving x dot equals to 0, there it doesn't characterize or it doesn't talk about only one point. So that point Hassan mentioned, that is when it is about all the roots or all the point which we can find from the, by solving or by equating x dot equals to 0. Now that is how the question that you asked, that is for what kind of perturbation or for what zone of the initial condition the system will come back to a particular equilibrium point, that is called region of attraction.
So, sir, like when you were defining equilibrium point, it was for like those systems which do not have any external inputs, right, sir? No U is there.
Equilibrium point means that here no external input, only non-zero equilibrium point.
Sir, what Hassan said, once you find those equilibrium points, those are isolated equilibrium points.
No, even it may not be isolated. It depends upon all the solution. Like suppose in case of the any linear system having like poles on the origin, there you like do not expect all isolated equilibrium points, right? So there it would be a continuum of equilibrium points.
So I think so with regard to this example, suppose if even that above equilibrium point, if that was the stable point, stable equilibrium point, if you perturb it, that means that it moves from this equilibrium point to that equilibrium point and then it stays there.
Yeah, so those are two isolated equilibrium points you're talking about. If
Yes,
it's a
yeah.
continuum, that is not the case at all.
Here, this is our continuum.
Yeah, that is isolated one place.
Now you see, that is what Hassan said, that is one of the first point, that is when you are solving x dot equals to 0,